but it'll be there probably within the next 2 or 3 days in case you need to see that. Okay, so the quadratic formula, what happens, and you don't have to write this down. I wish I had time to do this, but last class we learned how to complete the square. If you completed the square on this thing right here, you know what would happen? The quadratic formula would pop out. That's where it comes from. If you're really deeply interested in that, you could Google, where does the quadratic formula come from? And I bet you would be able to follow where it comes from, okay? Because it comes from completing the square. All right, so this is your quadratic equation. This is the formula using the A, B, and C that will solve any quadratic equation. Let's go to the next page and let's learn how to do this. Okay, so first of all, you have to understand that a quadratic equation always has an x to the second in it. It has to have that. It doesn't have to have the other terms, but it must have an x to the second. When you use the quadratic formula, the first thing you always do is make sure one side of the equation is equal to 0. Okay? Then what you do is identify A, B, and C. Those are just the numbers in front of x squared, the numbers in front of x, and then the other number. Then the third thing is you plug in the quadratic formula. If you want to check your answer, you got the ability to check and see if you're right. Okay? All right, so let's start going through some of these things then. So on example 5, this first one side is equal to 0. Always make sure that that's true. If it isn't, you got to make it happen. Okay? So what is A in this problem? A is the number in front of x squared, so that's 5. You want to just kind of write this down as we go through this. B is the number in front of x, so that's 7. And then C is -6. So you identify those numbers. It turns out those are the things that make the difference. Okay? All right, now for this problem, go ahead and write down the quadratic formula. You won't have to do it on every problem, but it goes -b plus or minus the square root of b to the second minus 4ac all over 2 times a. Okay, now what I recommend that you do is a good way to do this is when you plug these numbers in, use parentheses everywhere there's a variable. If students do this, they would avoid some of the common mistakes that are made in this. So what I'm doing is I'm just kind of replacing those letters, A, B, and C, with a set of parentheses. So I highly recommend you do that. You kind of set a little home for the numbers, okay? And using the parentheses will kind of help you evaluate these correctly. Okay, so what we do now is just plug it in. So let's see, B is 7, so the 7 goes there. 7 goes there. Just do what the quadratic formula tells you to do. You have 4ac, so the A goes there. The C goes there. It's all over 2a, so you plug that in. So my experience is students generally in a class like this, plugging into the formula is not a problem. That's not the problem. The problem is working it out in one particular case. Okay, so now let's put this together. So we have -7. Underneath the radical, you're going to have 7 to the second is 49. You can use your calculator if you need to. And then you can do anything you want to on the calculator if you have to. One thing you have here is, although that is a subtraction symbol with the 4, you can think of it as a negative. So you're really doing -4 times +5 times -6. You can do that in your head. I think that's 120. Or you could go -4 times 5 times -6, and that will give you a positive 120. Okay, and then do the denominator. 2 times 5 is 10. So you plug the numbers into the quadratic formula, then you start calculating either with the assistance of your calculator or without. Okay, so far so good. Okay, now work out what's under the radical. So you're going to need to do 49 plus 120, which is 169. If you need to use your calculator, you can. So now you're going to have -7 plus or minus the square root of 169 all over 10. Okay? Now, you got to get the 2 answers. The quadratic formula is going to generate 2 answers always. You may know what the square root of 169 or you may not know. I think a lot of students probably don't know. So if you needed to do the square root of 169, you're going to get 13. Okay, so now you're going to write down -7 plus or minus 13 over 10, and you still have a little bit more work to do to get your answer to the problem. Okay, all right, is everybody with me so far?
Yes.
Okay, generally I find using the quadratic formula is not too hard, but there is a couple of problems I'm going to do later that have a piece to it that you have to work on a little bit. So now what you do is you do this. You got to take this in two directions. You have to work out -7 plus 13 over 10, and you have to work out -7 minus 13 over 10. You have to work both of those arithmetic problems out to get your two answers. So this one would be 6 over 10, and 6 over 10 is a fraction you can reduce by 2 to get 3 over 5. So you do want to get a reduced fraction answer. You don't want decimals. You want reduced fractions. Okay, the next one, 7 below 0, 13 more below 0 gives you 20 below 0 over 10. That's -2. So those are the two answers to the problem. I'm going to, as I'm doing these problems, I'm going to write the answer in what we call a solution set. So I use that set symbol, and then -2 comma 3/5 would be the answer to that quadratic equation. Okay, and the thing about the quadratic formula is it solves them all. This one would have factored. We could have solved this by factoring. We would have got the same answer. Okay, so anytime the quadratic formula generates whole numbers and fractions, it means it would have factored anyway. Okay, so that's how that would go. That's a pretty straightforward beginning example. Okay, any questions? Does everybody feel okay with what I did so far? Okay. Okay, let's proceed to the next one here. Okay, make sure one side is 0, so that's good. Tell me what A is. 1, what's B? -16, and what's C? 64. Okay, use the signs. Okay, now this time I'm just going to do this. Whenever I do the quadratic formula, I just kind of go, in my head, I say -B plus or minus square root of B squared minus 4AC, and you want to, instead of putting AC, I'm going to put parentheses there. And then one big fraction bar all over 2A. Okay, do you guys ever heard the song Pop Goes the Weasel? Pop Goes the Weasel. Somebody on YouTube, people come up with stuff. There's songs that you can memorize this. It goes, it goes, -B plus or minus square root of B squared, subtract the 4AC, all over 2A. Impressed? There's another one for Notre Dame. Do you know the Notre Dame fight song? Okay, somebody came up with the Notre Dame fight song to do that. So all kinds of fun things on YouTube that I've seen. So quadratic formula is something that you need to definitely know how to do. Okay, so let's plug in on this. So we have the B goes here, and it goes there. That's where the B's go. You have 4AC, so the 1 goes there. The C is 64 goes there. And then all over 2A, you have 2 times 1. Okay, so the key thing, of course, is getting everything plugged in the way you need to. Okay, now you just work it out. Okay, so what do you think -16 is? That's 16. You always have that -B, so sometimes that changes the sign. Work anything on your calculator that you need to work out. So bring down the plus minus sign. If you do -16 squared, what's going to happen if you square a negative number? You're going to get a positive. And you need to work out on your calculator, fine. 16 times 16 is 256. Okay. And then you can do the same thing here. 4 times 1 times 64 is also 256. And then 2 times 1 is 2. So any of the arithmetic aspects you need to do on your calculator, that's acceptable. So you get 16 plus or minus the square root of 0 all over 2 like that. Okay, what's the square root of 0? 0, okay, because 0 times 0 is 0. So you end up getting 16 plus or minus 0 over 2. And again, don't stop that way. Get both answers. Now what happens in this case is if you do 16 plus 0 over 2, and then if you do 16 minus 0 over 2, you're going to get the same answer both times, aren't you? So you'll end up getting 16 over 2 is 8. And then if you do it this way, you're going to get the same answer twice. So the quadratic formula always gives you two answers, but sometimes it's going to be the same answer twice. So all you'd have to do on this one is just write your answer with that one answer. Okay, that's how that goes. Okay, so again, in this case, since we got a whole number answer, it means this problem would have factored anyway. So let me show you what I mean by this. So if you look at this original problem, you guys have worked a lot on your factoring and everything. Okay, just think about factoring. What are you going to use for the z squared in your two parentheses? Z and z. What are you going to use for 64? You're looking for two numbers that multiply to give 64 that add up to 16. 8 and 8. Look at that. You're going to have z minus 8, z minus 8. Wouldn't you have got z equals 8 if you did it that way anyway? Yeah, and it's a lot faster, isn't it? So if you're good at factoring, it's a lot less time intensive to just factor. You only want to do the quadratic formula generally is if something doesn't factor. If it doesn't factor, you're forced to do it. Okay? All right, everybody okay so far? Okay. Okay, now the next two examples have one little twist to it that sometimes students have to get past a little bit. So this one we have, on number 3, we have one side equals 0. So A is 1, B is -3, C is -7. Okay, so we're again just going to plug that in. This time I'm just going to put it together. Once you memorize the formula, you can just start putting it together. So you have -b plus or minus square root of b squared minus 4ac, and it's one big fraction bar all over 2a. So I like to just use parentheses in place of the letters in the formula. Okay, this will pop in like this. The -3 will go in those two places. The a goes in these two places, and then the c goes in that one place like that. Okay, so just make sure you have everything plugged in correctly using your parentheses. Okay, now here's what happens on this one. So again, you're going to have x equals +3 because a -3 is +3. Then under the radical, what's -3 to the second in your head? 9. -3 times -3 is 9. You know, be careful about that. You're squaring a negative, you get a positive. And then again here, you're doing -4 times 1 times -7, and that's a +28. So I see students miss the sign on that a lot. It's two negatives being multiplied. That's why I get a positive. Okay, now I've got the 2 times 1 is 2 like that. Okay, now we're just going to work it out. We're going to see where this leads us. This will be 3 plus or minus 28 plus 9 is 37 all over 2. Now what happens is sometimes your radical will be a part of your answer. You do not need to get your calculator out and do the square root of 37. I don't care about that. The square root of 37 is a bunch of decimals that go on forever with no pattern. We call that an irrational number. I don't want that. What you do is you can write the answer that way. That is an acceptable way to write the answer of this problem. If you want to write out both answers, then you write it out like this. In a solution set, you would say 3 plus square root of 37 over 2. That's one of your answers. The other answer is 3 minus the square root of 37 over 2 like that. So you can write the answer either way, but you need to understand that the plus and minus is an abbreviation for writing the two answers. That's all it is an abbreviation. Okay. Any question on that? Okay, so if the square root of 37, there's nothing you can do with that. Now, there are square roots that you can simplify, so we're going to look at that next here. Okay, question so far? Okay, number 4, what is the first thing you have to do before you plug into the formula? One side equals 0. Okay, what you need to do is just move the 3 to the other side. Okay, you want everything on one side. So we're going to go ahead and just write this as n to the second plus 8n What happens to the -3 when you move it to the other side? Okay, good. It becomes +3. You want to make sure you don't make that mistake. Okay. Now we have A would be 1, B would be the number in front of N, so that's 8, and then C is 3 this time. Okay. Now, same idea. It's just a matter of plugging into the formula. So it's -B plus or minus square root of B squared for AC. I got that stupid Pop Goes the Weasel song stuck in my head now. But whatever it takes for you to memorize it, you want to try to memorize. If you go into higher math, this is something you use quite a bit. So it's really important to memorize it. Okay, so now let's see. B goes there and there. And you have AC, so that's 1 times 3. And then you got 2A, so that's the 1 like that then. Okay, now this one right here has one feature that sometimes students struggle with a little bit. So watch how I finish this problem carefully. We're going to have -8 when we bring that down. Underneath the square root, 8 to the second is 64. 4 times 1 times 3 is 12, so we have -12. And then 2 times 1 is 2. One more step, we get -8 plus or minus. That would be the square root of 52 all over 2. So, but there's more you can do with this one. And this is the situation where students, more often than anything else, don't do well on. Okay, so we've talked about this before. This is one thing I reviewed, and I reviewed it for this reason. So when you're thinking of perfect squares, it's real important that you know perfect squares. You can generate the list very quickly in your head. Okay, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16, and so forth. Does everybody see how I'm coming up with these numbers? These are perfect squares. So what you look at is you need to see if 52 is divisible by one of these numbers. If you have to use your calculator, then do that. But you're always interested in these numbers. Well, 52 divided by 4, let's see what happens. That gives 13. So that means we have to break this up into 4 times 13. Okay? So the next step you take is you have -8 plus or minus square root of 4 times square root of 13 all over 2. You have to do that. Now on the 37, none of these perfect squares divide into 37 even. So that's why I stopped at 37. That's done. Okay, now the square root of 4 is 2. So now you write this as -8 plus or minus 2 times the square root of 13 over 2. And you're still not done. Okay, one more step. You have to learn to look for this. Okay, 8 and 2 reduce, don't they? So do 2 and 2. The best way to do this, the easiest way for a student to do this, is if you see that they both reduce. I mean, you can certainly do that in your head, but a good way to do this is just split it apart like this. Okay, you can just split it apart like that. That's just like the opposite of adding a fraction and getting a common denominator. It goes like that. Now, -8 divided by 2 is -4. And then the 2's cancel out to leave you square root of 13. That is the answer I'd be looking for right there. If you want to write two answers, you would write -4 plus square root of 13, comma, -4 minus the square root of 13. You're always going to have, in your quadratic formula, it's always going to have the same two terms. One's going to be plus and one's going to be minus. We call those conjugates, is the terminology for that. So that's the one, to me, that students have to work on a little more, is breaking up that radical. Okay? Does everybody understand what I did with that 52? Okay. So when you're dealing with radicals, it's not a bad idea to just write down perfect squares. Use your calculator to find the biggest one that divides into those numbers. Okay? Any questions? Okay. So let's do some problems in class. Let's do these three below here and see if you can get these worked out okay. All right? And you can work together and compare answers on these three problems. Okay, so I'll kind of see what you come up with on these three. And don't factor them. I mean, I can tell, and maybe you can too, that number one factors. I want you to use the quadratic formulas, and that's what we're learning right now. Generally do a little bit better if they learn to do this. This is one thing that I was trying to show you. The quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. This is what I highly recommend you always do. You don't have to, but it's a good strategy. Just do this. Before you plug anything in, use parentheses where those letters are, okay? Because the mistakes I was seeing were caused by the way you were plugging the numbers in. That's the first thing I saw. And that's real common at this level of a class. Okay, the good news is everybody knows that what the A, B, and C is, so that's not problematic. But when you plug it in, using parentheses will help you a lot. So you should have negative b, so that's negative 11, b squared, 4ac all over 2a. If you learn to write it real clean like that, you'll do a lot better. This one actually turned out pretty simple. This would be negative 11 plus or minus, that would be 121 minus 112 over 2. Use your calculator if you need to. So this would be negative 11 plus or minus square root of 9 over 2. And then the square root of 9 is 3. So you end up really just doing negative 11 plus 3 over 2. And you do negative 11 minus 3 over 2. That's how you got your two answers. And I think everybody made it through this one fine. Okay, this one was negative 8 over 2, so you got negative 4. The other answer is negative 14 over 2, so you got negative 7. Okay, so I'm pretty sure everybody got that right. There wasn't too much difficulty with that one. Okay, everybody solid with that? Okay, and what would have happened on this problem anyway is this thing could have factored as x plus 4, x plus 7. Okay, can you see after I factor it where those two answers come from now? Negative 4 and negative 7. So factoring's faster. Okay. Okay, the next one, there was a little bit more issues in the next one that I saw. That's because of the way the square root was. So what'll happen on this one, get this thing set here. Okay, on this one, we'll set this up like this. You got one side that's already equal to 0, so A is 4, B is negative 4, C is negative 5. So again, I'm going to go negative B plus or minus square root of B squared minus 4AC all over 2a. Get it set up. Just use parentheses, then pop stuff in. So now you're going to have negative 4 plus or minus negative 4 squared, 4 times 4 times negative 5. 2a would be like that. A lot of you messed up on this problem because you didn't write the negative 4. It's negative b. So I saw that on several papers. So you're going to get 4 now, plus or minus. Negative 4 squared is 16. Notice you have two negatives here. So a lot of you messed up here. A negative times a negative is a positive. That ended up being plus 80. A lot of you had minus 80 on that. Okay? Just learn from your mistakes. That's common. Okay, now what you get is 4 plus or minus square root of 96 over 8. And then if you got to that point, you've done all your arithmetic correctly. So you have to look at your perfect squares. Okay, you would find on this problem that 4 times 12 is 90, not 4 times 12, 4 times 24 is 96. But there's a better choice. There's 16 times 6. You always want to go with the biggest perfect square factor, okay? So this one you would write this as 4 plus or minus the square root of 16 times the square root of 6 over 8. Now that comes out of the radical, so you get 4 plus or minus 4 root 6 over 8, like that. Now, the reason you're not done is you have to be able to spot that both the 4/8 and the 4/8 reduce. Okay, they both reduce. They both have to reduce. So there's two ways to do this. The way that I showed you all how to do this was just to split it up. It's just as easy to do it that way. Split it up into two pieces, right? Okay. Then you would have 1/2 plus or minus 1/2 times the square root of 6. That would be one way to write the abbreviated answer. Okay, that's one way to do that, but you can't stop at this point because the 4/8 reduces. Here's an alternative. Sometimes students like this way better. You can also factor a 4 out of the top. If you factor a 4 out of the numerator, you would have 1 plus or minus square root of 6 all over 8. Now you got to convince yourself of what I did. See, 4 times 1 is 4. 4 times radical 6 is 4 radical 6. Now this thing reduces, so you could get 1 plus or minus root 6 over 2. That's another beautiful way to write the answer. I find that most students seem like they understand this way better than the other way. So it doesn't matter which way you do it, but you do have to go all the way to the end to get that. Yes. Yeah. The one's unnecessary. Okay. It's not wrong. It's just unnecessary. Okay. All right. Okay. Is everybody okay? What I did, how I handled the square root of 96? That's all key. That's what you have to get past. That's the hardest part of the problem for most students. Okay, this one, you have to distribute it first. So you would get 2k to the second minus 6k. You would have to slide the -3 to the other side. So you have to put it in standard form first. You had to do that. So a is 2, b is -6, and then c is 3. Okay, this problem is going to work out a whole lot like the one I just did. So you're going to do -b, so it's -6, plus or minus the square root of b squared. See, I'm using parentheses when I do that. Minus 4ac, again, using parentheses. And then all over 2a, like that. Okay, so if you clean up how you plug in, that will help a lot of you just with the little tiny mistakes you're making. Now you have 6 plus or minus square root of 36 minus 24 all over 4. So that's going to give 6 plus or minus square root of 12 over 4. Okay? Most students get to that point effectively, most of the time. Okay, what did you do with the 12? 4 times 3. Okay, you want to break it up into 4 times 3. So you have 6 plus or minus square root of 4 times the square root of 3 over 4. Square root of 4 becomes 2, so you get 6 plus or minus 2 root 3 over 4. Okay, do you guys know why it's not done? What reduces? 6/4 and 2/4 reduce. They both have to reduce, okay? If they still reduce, that means you can go further. So you can either do 6/4 plus or minus 2 root 3 over 4. You can take that approach, and then that would give 3 over 2 plus or minus 1/2 radical 3. That would be one way to write an acceptable answer, okay? The alternative way to do this is factor a 2 out. The greatest common factor between 2 and 6 is a 2. So if you take a 2 out, you'll have 2 parentheses, 3 plus or minus 1 root 3. You don't have to put the 1 there, though, over 4. Then you can reduce the 2/4 to 1/2. So you could write the answer as 3 plus or minus root 3 over 2. And you need to understand that these two answers are the same thing. And you all look at those two answers and tell they're the same. Sometimes students can't do that. If I split this up, isn't that just 3 over 2 and 3 over 2? The same answer. Okay? You got to take your pick as to which way you do that. Yeah.
Downside, so I was taught to leave the 2A, leave them separated to the last step.
Sure.
If you have that, then you can.
You can do that too if you want to. There's nothing wrong with leaving the 2A alone, and then you could cancel out a factor if that's helpful. It does not make any difference. Doesn't really make any difference. It's acceptable to do that, but it doesn't really make any difference. Okay, all right. Let's go to the next page. We're going to finish the next page, then I'll give you a break, okay? I can see people beginning to wiggle in their chairs and stuff like that. They're wanting a break. Let's just finish this up so I can finish up my recording, then we'll take a break, and then the second half of class we'll do 2.6. So you'll see this on web work, just a couple of basic applications. So this one says that you have an object, it's traveling, it's giving you some sort of a formula on here. It's giving you an equation. D is equal to, oh, come on, let's run this thing. Let me close OneNote, and sometimes if I close it and reopen it, it'll come back up. Okay, that usually fixes it. Okay, so you have a formula, distance equals 4t plus 5t to the second. So what you'll find if you study physics, and a lot of you are going to study physics, if you throw any object on planet Earth, it follows a path that's modeled by a quadratic equation. Okay, whoever wrote Angry Birds, they had to know about quadratic functions to make that thing follow that quadratic path. Behind the scenes, I guarantee it, there's a quadratic function on it on Angry Birds. Guaranteed. Okay? So what you need to know is with this is a quadratic function. So what it says is how many seconds will it take for the object to travel 67 feet? So that distance is 67, so you're just going to replace that d with 67. So you want to write down 67 equals 4t plus 5t to the second. Okay? Now, we're trying to find how many seconds it happens for that to reach that height. This is a quadratic equation. Okay? What do you have to do before you solve it, before you go to the formula? One side equals 0. Good. Okay? So I'm going to move it to that side, and you got to put these things in order. So you'll have 5t to the second plus 4t. When you jump the 67 over, its sign changes. Okay, now we're just going to do the quadratic formula, and it's likely on this problem that we'll have decimal answers. Okay, so basically in this problem, a is 5, b is 4, and c is equal to negative 67. Okay, so we're not going to try to factor it. It probably doesn't factor anyway. So we plug in, and we will have negative b plus or minus the square root of b squared, so that would be 4 squared, minus 4ac, so a is 5, c is negative 67, and then that's all over 2a like that. So this is the same kind of thing that you just got through doing and did a good job at. Okay, now work it out. You're going to have -4 plus or minus square root of 16 plus. Now I'm going to use my calculator on that. I'm going to do 4 times 5 times 67. And that'll give 1340. Does everybody see why that's a plus 1340? I see students do that all the time in this class. You have two negatives. Okay, that's why you get that. So now what we're going to get is we're going to get -4 plus or minus. That would be the square root of 1356 all over 10. Okay, now that's the part I think was just my observation. You all were doing a good job of plugging the numbers in and calculating and getting to this point. Now at this point, you don't need to worry about the 1356 and worry about perfect square factors. You're probably going to get a decimal on this anyway. So a good way to do this problem is like this on your calculator. I'm going to do -4 plus square root of 1356 over 10 on my calculator. Then I'm going to do -4 minus the square root of 1356 over 10 and do that on my calculator. Okay. So a good way to do this is just do it like in one step on your calculator like this. So just watch how I put this in. I'm going to do -4 plus square root of 1356. I'm just going to go ahead and get that answer. That'll give me a decimal. Then I'm going to divide that by 10. Okay, and I think the problem on here, doesn't the directions say round to 4 decimals? Okay, so that will be, we'll write that as 3.2824. Okay, that 3 needs to round up a 4 because it's followed by a 9. Yeah. Yes, yes, and you're thinking ahead, and that's fine. Though what I'm going to get on the next one is a negative answer. Okay, so what he's saying is if I put the next one in, -4 minus the square root of 1356, all you're going to do is get an answer there, and you're going to divide that by 10, and then this answer, the quadratic formula is giving you an answer of -0.4824. Okay, but what is t in this problem? T is time, right? Is there such a thing as negative time? Not for us, not for college algebra, okay? So in this particular case, there's only one answer to this problem. So the answer is 3.2824 seconds, okay? Yes. Yes, it is possible. You could end up with, every time you throw an object, it travels in a parabolic path. It is possible that you will reach the same height 2 times. Just didn't happen on this problem. So it is possible. Okay? All right. So it's a quadratic formula is what I did. Okay? Okay, any questions? Okay, let's do this last problem here. Okay, this is the fun one. You'll see this same problem on web work. I decided I'll just do the problem for you. So with this one, what this problem is saying is you have a kind of a garden. The part in green is grass. Then you have this concrete walkway around it like this. Okay, what the problem says is you're going to have an area on this of 550 square feet. That's the total area of this. What you're going to do is find the width of the walkway. Now, the width of the walkway is represented by x. Okay? You got to be able to put together a quadratic equation that'll solve this problem then. Okay, so try to think through it this way. This distance right here from there to there is 12 feet, right? What would this distance from here to here be? The whole entire distance. It's bigger than 12 by what? By 2 x's, right. You have to add on these 2 x's. So that distance is 12 plus 2x. Okay, it starts 12, but then you're adding on the 2 x's. So that's 12 plus 2x, okay? Look at this part right here. This distance here is 15, right? Well, what would be the big distance? 15 plus 2x, right? Does that make sense? It's x plus x is 2x, okay? So what you end up having in this particular problem, you have a rectangle with these dimensions. You have 15 plus 2x, then you have 12 plus 2x. Those are the dimensions. Does that make sense? Okay, now how do you find an area of a rectangle anyway? Length times width. Okay, so this would be, it doesn't matter which is which, that would be your length, that would be your width. So you're going to do the area is equal to length times width. So the length is one of them. We'll say that one is 15 plus 2x. Then the width is the other one. We'll say that's 12 plus 2x. But it told you the area is 550 square feet. So that is a quadratic equation that would model and solve this problem. Okay, is that logical? Okay. Okay, so let's see what happens on this one then if we figure this out. So what do you need to do? You need to multiply, you need to do the FOIL. You're not ready to figure out A, B, and C yet. So 15 times 12 is what? Is that 180, I think? Yeah, 15 times 12. So 180, so we would end up having the 550 equals 180, your outside term. 15 times 2x is 30x. Do your inside term. 2x times 12 is 24x. Do your last term. 2x times 2x is 4x to the second. Okay? So you can collect like terms. You would have 550 equals 180 plus 54x plus 4x to the second, like that. Okay? So now we're going to go the quadratic formula on this, but what do I need to do next? Move the 180, or not the 180, the 550. You got to get one side equals 0, so you'll have 0. And I'm going to rearrange how I write this. I'm going to write the 4x squared, then the 54x, then the 180 minus 550. Okay, you need to have, the highest power first and kind of write that in a descending order. So this is going to give 0 equals 4x squared plus 54x. And then I'll just take the calculator to do the next piece. So that's 180 minus 550. And that will be minus 370, like that. Okay. Everybody confident in what I'm doing? Okay. Now, you could factor it, or you could go to the quadratic formula. Which would you rather do? Quadratic formula, the reason I'd rather do is because the numbers are big, right? Okay. So we're just going to plug this in. We'll have negative b, so b is 54, plus or minus square root of b squared, so we'll have 54 squared. 4ac, a is 4, c is negative 370, over 2a, so a is 4, like that. Now you can do a few things on a calculator to kind of speed you up a little bit on here if you want to. One thing that you can always do is just kind of do what's under the radical. So if I do 54, let me clear everything on here. If I did this, you can do this if you want to. You can do 54 to the second, and then this would be two negatives multiplied, so it would really be plus 4 times 4, which you could do in your head, times 370. So you can work out what's under the radical in one step if you choose to. And I don't know what I did. If that ever happens, you can go to the go-to like this, and it'll tell you where your mistake is. Okay, you see what I did? I typed an extra symbol, okay? So what I'm going to do is I'm going to go 54 to the second. So 54 to the second, then I'm going to do, there we go, plus, and then plus 4 times 4 is 16. I'll do that in my head. And then times 370. And that'll give me a number, 8,836. So what I'm getting is negative 54 plus or minus square root of 8,836 all over 8. Okay? Okay, and then this would be what you would do to finish this up. You're just going to go straight to your calculator and do this. So you would do negative 54 plus square root of 8,836 over 8. Then you would do negative 54 minus square root of 8,836 over 8. And you may get two answers, you may get one answer. Okay, so again, I'm just going to do like this. Negative 54 plus square root of 8,836, get the answer, divide by 8, so that'll give 5. So who would have thought? What that meant is this would have factored anyway. I got a whole number, this problem would have factored, okay? I can do the other answer. Can you guys see that the other answer will be negative in your head? I guess some of you can, some of you may not be able to see that, but what will happen if you do the other one? You'll get this, divide that by 8, you'll get a negative answer. So you get negative 18.5. So remember, what is x? X is the walkway. Your walkway can't be negative, right? So that one makes no sense. So the answer of the problem would be the 5 feet. It would have to be. So these are essentially just a couple of little applications of quadratic functions and equations. That's what that basically is. Okay, rate your understanding. 0, anybody with 0? Okay, good. Anybody with 3? Not yet? Okay, getting close. You know, the biggest issue that I find in this section is working with square roots. If you get past that, you'll probably be fine with quadratic formula, right? Right? Okay, so let's take a 10-minute break. We'll come back and I'll give you the handout for 2-6, and then we'll go through quite a bit of it tonight. So 7:50, come back to 7:50, that's when I'll start the second part.